Hello students, welcome to lesson number 4 on trigonometry. I hope you are all doing well. Good. Now before we begin our lesson, let's take note of the following announcements. Right. Now, after watching this video, if you realize that there was a concept that you didn't understand, don't hesitate to give me a call for further explanation. Okay, so my number is on the screen. Okay, so on your screen you see a flyer which bears my number. So my number is 0245 507367. 0245 507367. So that's my number. Don't hesitate to give me a call for further explanation and clarification. Okay, on your screen also you see on the flyer that I run some online courses. Okay, so I have core maths for form 1 to 3 and then also NOVDEC student as well. Elective math 2 is part, chemistry, elective chemistry, form 1 to form 3 and then NOVDEC student as well. And then also matured entrance examination mathematics courses. Okay, good. So if you are in need of these services, or if you know someone who is in need of these services, don't hesitate to call me or give my number to the person for the person to call me for enrollment and discussion. Okay, good. And you will never regret, okay, you'll never regret having that classes with me, and it's very effective. Okay, so trust me, you will love it, and I'll teach for you to understand. Okay, good. So that is by the way. Right, so now let's move on to our lesson for the day. Good. So the last time we met, we looked at the last two parts of example 1, the questions there. Then I gave you example 2 as an assignment. So I did not even solve any of the example 2s. So I gave it to you as an assignment. And I hope you've all done the assignment. Good. So let's move on straight to the question. Now, we were told to find the value of x in the diagram below. Okay, so this is our diagram and we are to find the value of what? X, which looks like the slant height. Okay, good. So that is what we were to find. Now looking at our diagram, it looks like a trapezium. Okay, good. Now, and we've learnt about what? Right-angled triangle. So we have a slant height here, but we don't have a perpendicular height, so it is hidden in the diagram. Okay, so we have to bring out the perpendicular height so that we'll get a right angled triangle for this one to be what? Our hypotenuse. Okay, so you do that by showing what? Hidden lines from here down. Okay, so now that we have this perpendicular line, this angle here will be 90 degrees. Okay, so we now have our right-angled triangle, and then this x is what? Our hypotenuse, because it is facing the 90 degrees angle. So we can label this one as E. Okay, the new point down there. Good. So now that we have our right-angled triangle and we have to find the hypotenuse, we need the value of what? This perpendicular height and then this distance. Okay, good. So looking at the diagram, this height is the same as this height. Okay, so the height AB is the same as what? The height of CE. Okay, so it means this is also what? 12 centimeters. Good. So it's left with this side, that is DE. Now we're told, or we're given, that AD is what? 21 centimeters. So to find DE, we have to subtract AE from 21. Okay, because AE plus ED will give us what? 21. So when we subtract AE from 21, we'll get what? DE. Okay. And looking at the diagram, length BC is the same as the length of what? AE. So it means that length BC, and then it means that length AE is what? 12 centimeters. So this side is what? 12 centimeters. So when we subtract 12 from 21, we'll get this what? Length. And what will be that value? 9. So this is what? 9 centimeters. Okay. So from here to here, okay, is the 9 centimeters. And then from the A to the what? To the D, okay, is what? 21. Okay, 21 centimeters. So that is it. So we know this side, we know this side. So we can use Pythagoras Theorem to find what? To find this side. Okay, good. So now, with this type of question, it's advisable you sketch or you redraw the diagram, because you are adding on to it. So you redraw and then you use the diagram to solve for it. Good. So let's look at the solution. Good. So solution. Now always write the question number. So A. So we need the sketch of our right angle triangle. Don't mind my drawing. Now this is the X. Then this is the 90 degrees. So this will be E. Okay, E. And then this one will be what? C. And then this is what? D. Okay, so we got this one to be 9 centimeters, this one 12 centimeters. So from Pythagoras Theorem, CD squared is equal to CE squared, okay, plus DE squared. We want it to be in alphabetical order. So substituting, we have x squared is equal to CE is 12, so 12 squared plus D is 9, so 9 squared. Okay, so this is what we have. So now our x squared will be equal to, so what is 12 squared? So mind you, 12 squared is not 2 times 12. That is what most of you students do. It's wrong. 12 squared is not 2 times 12. 12 squared is 12 times 12. 12 multiplying what? Itself. Okay. 9 squared is not 2 times 9 or 9 times 2. 9 squared is what? 9 times 9. So take note of these small mistakes. Good. So this one will give us 144 plus this one will give us 81. So we now have x squared equals, so 144 plus 81, what will you get? Good. So you get 225. Okay. So we want x and it is squared. So what do? We find square root of both sides. Good. So x will be equal to plus or minus square root of 225. Okay. And this will give us what? Plus or minus 15. Good. So plus or minus, because the x2 can take what? A negative number. Negative number squared will also give what? A positive number. Good. Now we are dealing with distance, okay, and we don't have negative distance. So we have to use the positive value, okay. So we state the condition that our x is greater than 0. So it means that x cannot be negative. So our x is equal to what? 15 centimeters. Okay, good. So this is the answer to the A. This is the answer to the A. Good. Now let's move on to the B. Good. With the B, the question says we have to find wx to the nearest whole number. So always make sure you read the question to the end, to the nearest whole number. Okay, so this one should tell you that what you get is not in a whole number form, so you have to convert it. Good. So now, looking at the diagram, you realize that it's made of two right-angled triangles, a bigger one and a smaller one. The smaller one is inserted in the bigger one. Okay, now we are to find wx, which is this portion. But wx is part of the bigger length wy. Okay, so when we know the length of wy and we subtract xy from it, we'll get the length of what? Wx. Sorry. So it means that we need first the length of wy so that we can subtract the length of what? Xy from it in order to get the length of what? Wx. Okay, so that is basically what we are expected to do. So how then do we find wy? So wy is part of the bigger right-angled triangle. Okay, so from Pythagoras Theorem we can get the length of what? Wy, provided we know the length of what? Yz. Okay, because it wasn't given. The length of wz was given, that's the hypotenuse. Good. So it means that we need also to find yz. Okay, so when we find yz first and we use Pythagoras Theorem, we'll be able to find wy. Then we subtract 5 from wy to get what? Wx. So I hope you get it. Good. So let's move on straight to the presentation. Good. So this will be B. And once again, it's advisable to sketch the diagram. So we have this. Good. So this is 19.8 centimeters. And then this one will be our Z. This one will be our W. And then this one will be our Y. Okay. Good. Oh, sorry. We are using the smaller right-angle triangle. Sorry. Okay. Good. Good. So we have this one, rather. So this is Y, this is Z, and then this will be X. Okay, this is 13, this is 5. Good, and this is this. So from Pythagoras Theorem, xz, okay, squared will be equal to what? Xy squared. Okay, plus yz squared. Good. So now doing the substitution, you have 13 squared. Okay, then this one will give us xy was 5, so 5 squared. Then plus we need yz, so yz. Okay, we need yz. Good. So what is 13 squared? 169. Good. So we are going to have 13 squared minus 5 squared, okay, equal to yz squared. Because this is positive, when it crosses it becomes negative. Good. So now 13 squared is 169 minus 5 squared is what? 25, and it's equal to what? Yz squared. So when we do the subtraction, we are going to get what? 144. Okay, so we want yz, so we have to find square root of what? Both sides, because it is what? Squared. So our yz will be equal to plus or minus square root of 144. Okay, good. So on your calculator, square root of 144 will give us what? 12. So we have 12 plus or minus 12. So yz. Good. So we are dealing with what? Distance. Okay, so we don't need the negative value, we need the positive value. So we have to state the condition that our yz is what? Greater than 0. Our yz is greater than 0. Good. So greater than 0. So it means that our yz will be equal to what? 12 centimeters. Good. So that is the answer for yz. But we are not done, because we will need this rather to find what? Y. Okay, so we've gotten our yz to be what? 12 centimeters. Good. So let's check our diagram. Good. So we have found this. Okay, so using this one, we can find this one. So let's quickly do that. Good. So we have to sketch the bigger right angle triangle now. Okay, so this is this will be the z, this is w, and this is y. We found this to be 12. This was giving us 9.8. Okay, so we need wy. So from Pythagoras Theorem, wz squared is equal to what? Wy squared plus what? Yz squared. Okay, good. So substituting, our wz was giving us 19.8. We have to find wy, so we'll maintain it. Then yz, we found it to be 12. Good, so we want wy, so you're going to have 19.8 minus 12 squared. Okay, good. So we send the 12 there, so it will be negative. Good. So what is 19.8 squared? So we'll need our calculator to do this, okay, because it's quite difficult doing it with your head. Good. So let's get our calculator. Right. So now we have to punch it as we see here. Okay. So in brackets 19.8. No. So in bracket first we are using the squared one. So 19.8. We close the bracket. Okay, so that's what we have. Then we punch equal to. So it will be given in this fractional form, but we want it in a decimal form to help us to compute it easily. So to get it in the decimal form, you have to press this key, the SD key here on top of the delete. Okay, so it's good. So pressing it gave us what? 392.04. Good. So let's write that one. So we have 392.04. Then minus, for 12 squared is easy. It's what? 144. Sorry. Good. So we now have wy, okay, squared to be that. Good. So we have to subtract 144 from 392.04. Okay, good. So let's rearrange it. So we have wy squared is equal to, so doing the subtraction, okay, we'll need our calculator again. Okay, good. So let's on it, put it on to get it restarted. So now you punch it as you see. So 392.04 minus 144, okay, equal to, good. So we are getting fractional form again. So you press this one. Good. So we have 248.04. 248.04. So 248.04. Okay, so that is when we do the subtraction. This is what we are going to get. So we want only wy. So we have to find square root of both sides because it is what? Squared. So wy is going to be plus or minus square root of 248.04. Okay, good. So still we'll need the calculator. So when you punch it on your calculator, what do you get? Square root of 248. So square root of 248.04 equal to, good. So we have it in fraction again. We press this key to get it in decimal. So we have 15.7492857. So let's write that one down. 15.7492857. Okay, plus or minus. Good. So we need the positive side because we are dealing with distance. Good. So we have wy greater than 0. So our wy is now equal to 15.7492857. Good. Now at times the numbers are too long, okay? So it's accepted when you approximate it to 4 decimal places. So either you write everything or you approximate it to 4 decimal places. Okay, good. So we now have the answer for wy, which is 15.7492857. Good. But we are not done. So let's go back. Good. So we found wy, but the question said we should find what? Wx. Okay. So we know that wy is what? Wx plus what? Xy. Okay. So let's do the put down the relation then we saw for Wx. Good. So we know that Wy is equal to Wx, okay, plus Xy. Good. So we found the Wy to be what? 15.7492857. So you have to use the raw value. Then we maintain our Wx, okay, plus Xy was given as 5. Good. So now we are going to get 15.7492.857 minus 5 equals Wx. Okay, so let's do the subtraction. So when you subtract 5 from it, okay, you are going to get what? 10.7492.857 Wx. So let's rearrange it. So our Wx is equal to 10.7492.857 centimeters. Okay, good. Now mind you, we're told to find Wx to the nearest whole number. To the nearest whole number. So we have to do that. If you leave your answer here, you have not answered the question. So you lose mark for the final answer. Okay, so always make sure you approximate it to whatever approximation the question requires you to do. Good. So for us, we have to change this one to the nearest whole number. Good. So we do it by checking the value after the decimal point. Okay, so we have 10 points. So after the decimal point, the value there, that's what we focus on. If that value is 5 or more, we'll add 1 to the ones position. Okay, which means we'll add 1 to what? To the 0 here. Okay, but if it is 5 or less, we ignore it. So in our case, the number after the decimal point is more than 5. So it means that we'll add 1 to the 0. Okay, good. So when we add 1 to the 0, we get what? 11. Then we forget about the others. So you have 11 because this is the nearest whole number. 10.7 is closer to what? 11. Okay, more. Good. So we have 11 centimeters. Good. So that is the answer for the B. So the B, the value of Wx to the nearest whole number is 11 centimeters. Good. So students, this is how far the Lord has brought us. Good. So take your time, go through the presentation, compare it with yours. Where you didn't get it, make sure you do the correction. If you also got the same thing as I did, then you've done well. Clap for yourself and keep it up. Okay, good. So we'll end here. And then we'll continue next time. Okay, so till we meet again, revise, read ahead. Okay, revise and then read ahead. Our next lesson will be on Pythagorean triplets. Some people also say Pythagorean triples. So that is what we'll be looking at in our next lesson. So make sure you read about that one before we meet. And then after that, we'll zoom into what? Trigonometric ratio. Okay, good. So till we meet again, bye.